Welcome to this first summary lecture of our course 11.121, Termisk Bygningsfysik. The course is in Danish, but we will make short summary lectures in English. So the English term for the course is Thermal Building Physics. And this is the introduction to the heat transmission lectures. There will be 3 more lectures on the specific heat transmission parts, as we're going to see soon in this little lecture here. We have heat transmission from our buildings, which are normally heated, compared to the outdoors, where it's colder, at least in Denmark. So we have heat transmission in that direction from cold to the outside. Sorry, from warm to the outside cold. And this heat transmission has different elements by the mechanisms that we will illustrate here in this little lecture here. So we have 3 basic forms of heat transmission: heat conduction, convection, and thermal radiation, and we will have separate lectures for each of those. But here we'll just see in this lecture today how they go together conjunctly to form the heat transmission parts for the building elements, like for instance the walls or the roofs from the slide you just saw before. So we have the requirement that there will be a temperature difference, so altogether the heat flow is from the warm towards the cold temperature. Also, you can imagine in a room where you might be standing here in front of a wall with a solid material, then we'll have the conduction to take place there, but also through the air you can have the feeling of convection, warm, for instance heat coming from a radiator, but also by radiation you can also sense the heat that comes from the radiator. So that's what you can consider this question here. How do you feel those 3 transport forms if you were a person standing here in this room and being exposed to those transmission forms? So heat transmission, that is by definition, a spontaneous, irreversible transmission of heat between bodies that have different temperatures. And then, as has been said already, well then the heat is delivered from the warm towards the cold body, and that's our heat transmission. And second law of thermodynamics tells us that the heat will not spontaneously return back again. So it is a transmission, yes, again, from warm towards cold. And we have the 3 different mechanisms here. They have separate lectures, I've said already, but just very briefly, heat conduction is transmission of energy internally in a material where the collision of atoms in the materials, vibration for instance, will move heat from warmer to colder parts without causing really a transmission of material as such. Unlike in convection, then you have movement of something in a fluid like a gas or liquid. Well, then with the movement comes also a movement of heat that follows with the mass that flows around locally in an environment. That's convection. And thermal radiation is different. That is electromagnetic radiation between surfaces that are facing each other, so they kind of see each other, and that then causes radiation as a heat transfer mechanism there. So specifically, we'll see to those later. But now today, we'll just, by means of an example, we'll just see how those 3 mechanisms function together. Our example is a roof, where we have a solid roof board, we have a solid ceiling board, and we have a solid joist or beam here that joins the construction. We have also a thermal insulation material, which is also kind of a soft solid, if you will, where we also have conduction. So conduction we have in all the solid materials. In the cavity, the air that is here between some of the materials, then we have the other forms of heat transport, which is convection and radiation. And we see letters here, they are in Danish, and I'll explain shortly why. So K is for convection, S is for radiation, as we have it down here, over the air spaces, and also then in the solid parts, then we have the conduction. L for ledning in Danish, S for stråling in Danish, K for convection in Danish. But the problem is, if we make completely the translation to English, we'll have too many C's. So I hope you can cope with the little bit Danish abbreviations here to make the translation. Also, I should mention finally at our exterior surfaces and interior surfaces, we also have heat transmission from the roof towards the outdoor and indoor environments, and that takes place also by convection and radiation. Finally, there are some other transport forms whereby we have a macroscopic flow of air, for instance, all the way through the roof that might carry some heat also. And if we have some droplets of water that could evaporate or condensate, those condensation and evaporation mechanisms also comprise some heat transfer mechanisms as such. They are a little bit special, so for now we'll consider only the three main parts here: conduction, convection, and radiation. So we'll use, to illustrate this and to make it possible to calculate, we'll use some block diagrams that illustrate the individual heat transmission paths for those three basic transport forms. Each of them represent kind of the resistances. So a resistance is one little elementary flow, as we'll have it. And the resistance is noted by the letter R, and the unit, of course, square meter Kelvin per watt. And that is also, working with resistances is what also electrical engineers, for instance, do. So it's quite analogous to what is done in other engineering fields. But what is important here is that those couplings, those transmission paths, could be either in series, one after each other, or they could be in parallel to one another. And we have to mathematically be able to treat those combination forms here. And that's why we continue looking to our example, our roof, a little bit magnified again. So here we see those block diagrams that illustrate the transport forms. We have convection and radiation at the outside of our roof. Through the roof board, we have conduction. Over the cavity here, then we have convection and radiation. Then we have conduction in this insulation material and in the ceiling, those two after one another here. And then inside we have again convection and radiation. So when we have those two coming together, convection and radiation, then we have those parallel paths. And for those that come one after the other, we couple them in series, so one after the other. That was shown now for the transmission path A. Likewise, we could have talked about transmission path B, where it's only conduction through the three different solid materials that our roof consists of. And that is shown out here on the right part of the screen. Now, let's focus a little bit more on how to calculate the overall effect of those couplings of the paths here. So we take now again only section A as our path through the roof here. And we'll, now those resistances, we'll put a number to them to see how we can put some formulas to it. And we'll look to those series and parallel couplings. So here on the next slide, we will see a little bit more about that. So for those resistances that are coupled in series, so one after the other, for instance, the insulation and the ceiling R6 and R7, when we should have the total resistance of those two together, we simply add them up to one another. Now, if we look to the ones that are in parallel, that could be the convection and the radiation over the cavity in the middle of our roof. Well, then the formula for parallel couplings of resistances is that 1 over the effective resistance of those two together, for instance, R4, 5 here, is 1 over R4 plus 1 over R5, or we can isolate R4, 5 by this formula as we have here. So that is the calculation mechanism, and that means now, and that would be my final slide for this little introduction lecture here, now the whole roof in section A, as we've seen it now in the previous slides, the total resistance of the roof in all those working together, we take here by those couplings where we have parallel, 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 and all those we then add up because they come after each other. For the series, we simply add them up. So this is our way to calculate the total resistance of our roof. And as I've said already, in the subsequent lectures, you will see more in detail how to calculate resistances for conduction, for convection, and for radiation. So hang on for the next lectures and see how we follow up on this theme. Thank you for listening into this.